Right, this is actually third time lucky with this question one. The first twice I've done it, I've made a mistake. So, particle Q of mass 2 kilograms moves on a horizontal plane due to the action of a force F newtons. The force applied causes the particle to move with a velocity given by that. So you can see there it's got a variable t, which means the velocity is going to change. It'll have a different value for different values of t. That means the acceleration is also variable, and because of that we're going to be using the variable acceleration, not the constant acceleration mathematics. So find an expression for the acceleration of the particle at time t and the magnitude of the force at t equals pi by 4. So the velocity we can see is also given as a vector, but that's nothing to sweat about. It just means that it's giving you in one line the horizontal component and the vertical component. So in order to go from velocity to acceleration, we know that that requires us to differentiate the velocity vector. So when we differentiate this, we can see here we've got a chain rule. We've got the 3t inside the sine function. So that's going to be 6 sine finger. When you differentiate that, you get 6 cos finger, which is multiplied by the differential of what you covered up, which is 3. Using a black pen, which I smudge. Minus, and then when you differentiate cos, you get minus sine, which means that's going to become plus 4 sine t j. You don't need to have the t in brackets or the 3t, it just helps you see that that's part of that cos and sine function. So A will be 18 cos 3ti plus 4 sine tj. And when we were doing vector work, I was basically saying you could write it like that with i's and j's, or if you wanted to, you could write that as a column vector with the 18 cos 3t on the top of the column vector and the 4 sine t underneath. So that would mean exactly the same thing, however you're happiest working with it. So that's the expression for the acceleration, but then it's asking as well for the magnitude of the force at t equals pi by 4. So let's first of all work out what the acceleration is at t equals pi by 4. So I'm working with differentiation, and I got trig function, so I know I need to be in radians, and the other trigger there is time is given in terms of pi. My calculator at the moment is in degrees, so I need to shift set up angle unit 2. Then I'm going to store pi by 4 in x. So this one then is going to be 18 cos 3x, which will be minus 9 root 2 I, and then 4 sine x, oops, which will be plus 2 root 2. So that's what the value of the acceleration is at t equals pi by 4. Now for the force, I'm given a mass, I know an acceleration, so I know that Newton's second law, F equals ma. The reason I'm underlining these is because they're vectors. If you were typing it, you'd have them in bold. So the force is what I'm trying to work out. The mass is 2. So the force is going to be minus 18 root 2 I plus 4 root 2 J. Now that's the vector form of the force. The question's asking for the magnitude of the force. So just to remind you how you get that from the vector form. When you got the vector form, let's say you've got something like 3I 4J. The magnitude is your hypotenuse. So that side would be 4, that would be 3. So if we got F equals 3I plus 4J, the magnitude you get using Pythag. So that would be 3 squared plus 4 squared. So the magnitude would be 5. And if they ask you for the direction of the force, you would use trig, opposite adjacent, tan of the I component over the J component. So the magnitude is from Pythag and the direction is using trig. So in this case, the magnitude of F is going to be minus, so the square root of minus 18 root 2 squared plus 4 root 2 squared. So square root of 18 root 2 squared plus 4 root 2 squared. So that's going to be 2 root 170 or 26 newtons to two significant figures. Okay, so that's part A. Part B, given that when t equals 0, Q has the position vector 3i plus 2j relative to the origin, find an expression for the position vector. So now we're going from velocity vector to position vector. Velocity to acceleration is a differentiation. Velocity to position is an integral. Okay, and when we work with vectors, the position vector tends to have the variable r, but that could be x or s. It all means the same thing. So we need to integrate 6 sine 3t I minus 4 cos t j with respect to time. Okay, so when we integrate sine, we get minus cos. So that's going to be minus 6 cos 3t, and then we're reversing the chain rule. So rather than multiplying by the differential of that, which is 3, we divide. So that's going to be that I. And then when we integrate when we integrate cos, we get plus sine, which means that will stay negative. So that's j. And then, of course, we've integrated, we haven't got limits, so we have to include the constant of integration. So r will be minus 2 cos 3t, because the 3 will cancel into the 6, I, minus 4 sine t j plus a constant. So we now have to see what information they're giving us to manage that constant, and they're telling me that at t equals 0, the position vector is 3i plus 2j. So at t equals 0, r is 3i plus 2j. So 3i plus 2j equals, cos of 0 is 1, so that will be minus 2i. Sine of 0 is 0, so that will go to 0 plus c. Take the 2i over and it becomes 3i plus 2i is 5i, so c will be 5i plus 2j. So when I include that now into my position expression, so therefore r will be, so we've got a 5i and that's negative, so I'm going to put the 5 first, minus 2 cos 3t I, and then similarly here I've got 2j minus that, so plus 2 minus 4 sine t j. So let's go back to the question. Find an expression for the position vector of q at time t. So that's that done. Part C, hence determine the distance of q from O at time equals pi by 4 and its direction of motion. So that's, as I was describing earlier, the distance will be given by the magnitude of the position and the direction will be given by the angle. So first of all, let's work out what the actual position vector is. So r will be 5 minus 2 cos, and then instead of 3t it's going to be 3 pi by 4 I, plus 2 minus sine pi by 4 j. And on my calculator, when I evaluate these, I'm going to store them as variables so that I can just recall them into my Pythag and trig. Right, so I'm still in radians. I've still got pi by 4 stored as x. So this first one is going to be 5 minus 2 cos 3x. So that's 5 plus root 2. And as I said, I'm going to store that in A. And then this one, 2 minus sine x, is that. So plus 4 minus root 2 over 2j. And I'm going to store that in B. Right, so to determine the distance, will be the magnitude of r, and I can just write that now as a squared plus b squared. So square root alpha a squared plus alpha b squared equals, so that's going to be 6.5 to 2 sig fig. And then the direction is going to be inverse tan of the j component over the I component. And now we need to be in degrees because that angle is measured in degrees. So now I need to cancel that, go back into setup, angle unit, degrees, shift tan, fraction, alpha b over alpha a, close bracket. So it's 11.4 degrees. 11 degrees to two significant figures. So hopefully on that third attempt I haven't made any slip-ups. So I made that question up, which is why some of those numbers are a bit bonkers. The question you're going to get on the exam paper should be a little bit more straightforward.